All right, so starting today, we're actually going into what I consider real Math 1 material. The material that we've been in up to now. If you don't have a packet, you need to go get one. If you don't have a packet, you need to go get one. The material we've done so far is stuff that you really should have been doing and have done in middle school, 8th grade, some of it's 7th grade, maybe even some of it's 6th grade. But the stuff you're gonna see starting today, you have never seen before. So this is the beginning of the real Math 1 material, in my opinion. With Math 1, we study 3 types of functions. You don't have to worry about what a function is yet. I'll tell you a function's like an equation. But we call them functions for a reason, and we'll get into that later. But we study 3 types of functions. We study the linear, the quadratic, and the exponential. There's lots of other functions. There's circles, there's hyperbolas, a sine. There's lots of other functions. But in Math 1, all we study are linear, quadratic, and exponential. If you will turn in your little booklet to, I think it's turn the page twice and you'll see where it says day 1. Turn it twice and you'll see where it says day 1. And for those of you watching, I'll have this up on your Google Classroom during my planning. Okay, so we're on day 1, but right now we're going to turn to the other page, flip it over, and I want you to look at this up here because you have to make a change up there. When we are dealing with using desmos, which in Math 1 in North Carolina, they've released a program called Desmos. It's a calculator program, and it does most all of the work for you, and it's wonderful because back in the day we had to use the TI-83s and 84s, and though they were awesome, and I still use mine, and you guys have used them too, but you've used them for minor calculations. You haven't used them for doing some of the stuff we're getting ready to do. The calculator required a lot of knowledge and a lot of ability to put things in, whereas Desmos does not. Yes, Ava?
I have a TI-84. Can I use it?
You cannot. You will have to use, you'll see why when we learn it. So, we're going to study 3 types of functions. We study linear. Well, obviously, linear means it's a line. And it could be a line that's got a positive slope, a negative slope, straight across, straight up and down. A line is a line. A line means it has no bend. Some folks aren't taking notes and some folks aren't even paying attention. This will not be good for you here shortly, if you're not. So, linear. As far as Desmos goes, the form that we're going to be using for Desmos is y equals mx plus b. I'm not sending anybody to the bathroom right now. I don't even know who that was. Don't ask to go to the bathroom when I'm in the middle of a lecture. That doesn't even make good common sense. Y equals mx plus b. Now there's something called tilde you're going to learn today, and you have to use tilde today, and we'll explain why in a minute. Tilde looks like this. And I'll show you where it is in a minute. Y, anytime you use Desmos, anywhere you put an X or a Y, you have to put a 1. It's a subscript. Y1 tilde, mx1 plus b. That's what it's going to look like. Y1 tilde, mx1 plus b. You're going to be using tilde to get equations. You're going to use tilde when we start comparing data. You'll become very familiar with tilde. I need all computers shut. We are not doing anything on a computer right now. Okay, thank you. So that is our linear. If we're doing something with quadratic, that's the next function we study. If we're doing quadratic, quadratic looks like a U, or it might look like an upside down U. It could look like either one. If you see that shape, you know you're dealing with a quadratic graph. And a quadratic graph, Matt, I'm gonna need you to get a pencil and take some notes, okay? Quadratic graph, you're gonna use y1 tilde ax1 squared plus bx1 plus c. This will make sense in a minute. That's your quadratic, if you're dealing with a quadratic. And the last one is exponential. If you're dealing with exponential, exponential is kind of a half a parabola, kind of straight, and then it curves up really fast, or it could curve down really fast. It could be either shape. It could do this and curve down really fast. Exponential, you'll use y1 tilde ab raised to the x1 plus c. Those are your three forms. You will notice, you will see almost the same forms up here where they give you the forms, but with the quadratic, I've given you something different than they have. You might want to mark through that and put the one I gave you. They gave you something called vertex form. We don't use that. We have to get a packet back there. We don't use the vertex form, so you would change that to what I just gave you. And the exponential, they left the plus c off. You'll want to put the plus c back on. Okay?
This is for when I was,
So, now, when we go into doing something with our data, as long as we know what it is, we're going to pick which one of these forms we're going to use. And we're going to be doing that in just a minute. Now, when they give you data, like they may give you a table of data and say, okay, with this data, I need you to tell me what x is when, or what y is when x is 1,000. Well, that would be impossible if you don't know what kind of data it is. So that's why we have to know what kind of data it is. If we can find out what kind of data it is and then get the equation, then I can plug 1,000 in for x and I can find the answer to that problem. But if I don't know what kind of data it is, I can't do that. That wouldn't work. So when we go, and I'm going to switch screens in just a minute, I'm going to switch to my other computer so I can show you how this works. But when we do that, you're going to be dealing with something called tilde. Your tilde key is this right here. So if you'll open your computer and just look at your keyboard and find that key. You're not going to do anything with it. Just make sure you know where it's at. And the way you access it is through Shift tilde. Okay, we'll be using that little key a lot. Now, I'm going to teach you how to use the desmos completely to do what we're getting ready to do, but I also have to teach you by hand because some of this, we have 18 problems on the EOC that are hand. There's no calculator available. So you have to know how to do it by hand. So when we are dealing with testing data, there's something called a first change. I call it a first change. I think they call it differences. They call it first difference, second difference, or you can say first change, second change, or multiplication. That's going to tell you what kind of data you're dealing with. So if you guys will find this page on your pamphlet, find this page, I'm going to show you what they're doing. First thing you want to do is you want to make sure that your x values are constant, meaning one after the other somehow. It could be 2, 4, 6, 8, where they're skipping 2 each time. That would be fine. 1, 2, 3, 4, where they're consecutive. That would be fine. What they can't be is like 1, 2, 8, 6, 14, where they're skipping around with no rhyme or reason. That they can't be. So when I look here at 2, 3, 4, 5, 6, 7, okay, they're adding 3 each time, but it's constant. Now, once I determine that, I go over here and I say, well, what's going on over here? From 4 to 3 to 2 to 1, they're subtracting 1 each time. This is called a first difference or a first change, however you want to call it. I call it change, a first change or a first difference. If ever you see a first change or a first difference with data, it's linear data. No question, it's linear. That is linear data. So right here they've said linear function. That told me it's a linear function. Now the interesting one, which is my favorite actually, is quadratic. I go over here and I first look at the x values and I say 0, 1, 2, 3, 4. Yeah, that's constant. That's good. We're good. Now, 3 to 2, they subtracted 1. 2 to 3, they added 1. I don't have a constant thing. 3 to 6, they added 3. 6 to 11, they added 5. That's what they did here. Well, I'm not going to stop. I'm going to try it one more time and only one more time. From -1 to +1, they added 2. From 1 to 3, they added 2. From 3 to 5, they added 2. They have a constant second difference or change. If it's a constant second change, it is quadratic data. Do you guys understand what I'm saying so far? Yes.
So you said differences are only linear, but quadratic has a difference.
What now?
You said if there's difference, that means it's linear.
If it's a constant first change, if I find that pattern the first time, it's linear. If it takes me 2 times to find that pattern, it's quadratic. Maybe that makes more sense. If, in fact, everything's constant here, when I go over here, I see they're multiplying. And they're multiplying by the same amount. Anytime there's multiplication or division involved, that's exponential data. Exponential data. Do you guys understand what I'm talking about? Okay. So let's look at this first table right here. I want you first to say from -2 to -1, 0, 1, 2. This is constant. They're going up by ones. I want you to see what's going on over here. See if you can do this and see what's going on over here on the y's. I'll give you just a second to do that. And you can do it just the way you see that they do it. And then name it. What is it? Is it linear? Is it quadratic? Or is it exponential? Well, when I look at it, I've got 7 to 4, they went down 3. 4 to 1, they went down 3. 1 to -2, they went down 3. And -2 to -5, they went down 3. So what does that make that?
Linear.
Linear. This is linear data. Now, if they asked me for an equation, which they didn't, but they're going to on the ones when you turn the paper over. If they ask me for an equation, that's where I have to use desmos and I have to use that tilde. And I'm going to show you how that works. So everybody has their data. We're just going to look at I want you to open up go to your computer, open up a second tab and go to desmos. DESMOS, it'll pull up graphing, and that's what you want, desmos graphing. Should bookmark it if it's not already, because we'll be using it a lot.
It's not doing my computer to turn it on.
It what?
It's not turning on.
Must be dead. You're supposed to charge them at night. All I can tell you is you have to go back there and go back and get one of mine. Use it. I need y'all to charge your computers at nighttime. Otherwise, you can't expect it not to be dead. Okay, so when you get to Desmos, this is what you should see. You have a great big area for graphing. Your graph will show up over here as you put data in. Then over here we have this little thing, and this is what we're going to be using a lot. I'm going to want to create a table, so since I know that data I just worked with was linear, I already know what it is, I know which form I can use, which is y1 tilde mx1 plus b. But before I could do that, I have to enter the data in a table. If you will go to this little plus sign right here, click the plus sign, and then you will see where it gives you an option for a table. Click the table, and it will give you a table. Okay? Now, we're going to go back to our data, which was on our x side, -2, -1, 0, 1, and 2. You'll see when you put that in here, it's going to automatically, on the x side, not the y side, it'll automatically figure what you want next. Watch how that happens. So I'm going to put in a -2 on the x side, -1, and now it's going to know what to do. 0, 1, 2, and that's 2's as far as I want to go. I'm going to now go to the y side, and it won't do it for the y's. You just have to input those. And on the y, I'm putting 7, 4, 1. Is everybody with me? -2, -5. Everybody with me? Okay. So what we're doing is we're putting data into desmos that we've already been given. We know the data. We have already decided what it is. What is it again? What kind of data is it? Linear. And we know it's linear because?
It's constant.
Constant, which change? First change. There's a constant first change, so we know it's linear. There's no question. But we don't know is the equation. And that's what we want. Okay, what we're going to do in order to get this equation is we're going to click right below this line here. So click below that line. It's going to open up another little box. And we're going to put in that linear form we discussed. Y, everywhere you put a Y and an X, you have to put a 1. So Y1 tilde, that's your shift. I showed you where that key was already, right? MX1 plus B. When you guys put that in, I want you to notice right here, it tells you the value of M, and it tells you the value of B. If I have the value of M and I have the value of B, I have the equation. So who would like to tell me what they think the equation must be? Anybody? What do you think the equation must be? They give you M. Here's the form. What do you think, babe? Beautiful. That's it. You plug the -3 in for the X, or for the M. So you've got Y equals -3X, B is 1, so it's +1. That's your equation. And that's what we were out for. We're out to find out what is the equation. Now if I said to you, let me go over here, let me change this over so it can see what I'm doing on the board. Okay, now I know what the equation is. I know the equation is Y equals, was it negative? What was it?
-3.
Positive 3 or negative?
-3.
-3x
Plus 1.
+1. Okay. Now that scenario I told you about earlier, I said, well, what if I said, what does y equal when x is 1,000? And we couldn't answer that because we didn't know what kind of function it was. Now we know what kind of function it is. So if I plug 1,000 in for x, I have a -3 times 1,000 plus 1. Y equals -3,000 plus 1. Therefore, y will equal what?
-3,001.
Negative what?
Never mind.
What would it? What's -3,000 plus 1?
Negative 2,999.
That would be your answer.
Will it give us what x is in the question?
Yeah, well, they will tell you, what you'll do is they'll give you the data. Okay, let's recap. They'll give you the data. You'll do the hand thing that we just did. You'll determine what it is. Is it linear, quadratic, or exponential? Then you will go into the computer and you'll put that data in the table. You'll do the tilde thing, and you'll gain your equation. Write your equation down. then they'll say, you know, they'll give you a situation. So if x equals whatever, you know, what's f of x or something like that. So they will tell you yes.
Can we use desmos on the final?
I can't hear you.
Can we use desmos on the final?
Absolutely. There's 18 problems on the final. This calculator inactive. You can't use anything but your brain. But after that, they have a desmos built in. I'm also allowed to give you the calculators. However, and I will. I had kids use them for minor calculations. But for this kind of stuff, I'm not teaching it on the calculator. I'm only teaching in desmos. To do what we just did here in the TI-83 would take 15 minutes. It'll do it. And we used to only have that. We didn't have desmos, but it's very involved. So you don't want that. Okay, so what I would like for you to do now is I would like you to look at that, where are we at here? Look at B and C, and I want you to go ahead and see if you can find a first change, second change, or multiplication and division. Find out what it is. Is it linear, quadratic, or exponential? Then I want you to see if you can go ahead and put it in desmos with tilde and gain the equations. Yes, Ava?
So how do you know if it's exponential or quadratic when it's like on C? Does it be both?
No, it can't be both. What do you mean on C? So you got 6, 3. Tell me what would you consider it? Both what?
Like it could be time stuff, but it could also be subtracting or adding.
Would it be constant the entire way?
No.
No.
But on quadratic function on the top one, it isn't constant.
Let me see what you mean. I'm not sure what you mean. Show me what you're talking about. It's not constant on the first one. That's why you had to do it again. It is constant on the second. That's what makes it quadratic. No, because quadratic looks one way and exponential looks another way. Now, though exponential looks very much like a quadratic, it's half there, but an exponential is going to be requiring multiplication or division to get to that next point, whereas quadratic does not. You will see as we do, because this is brand new to you, you will see as we do these what I'm talking about, okay? So just right now, bear with me. Let's go ahead and let's find our changes, find out what kind of data they're giving us. See if we can find the equation. I'm going to switch over to the iPad now. So we found the first change. I'm gonna go ahead and over here. You know what, guys? When I see a decimal, what does that probably tell me it is? Yeah. When I see a decimal, I not always, but right away I'm like, I think that's gonna require multiplication. If from here to here to here to here and here to here requires multiplication. And since a lot of us don't do decimals, don't want to look at decimals, I'll skip it. I'll go down to 3. What do I do from 3 to get 6? I could add 3, right? But if I add 3 to 6, am I going to get 12? Okay, so it can't be that. So then I'm going to say, okay, well, 3 times 2 is 6. Is 6 times 2 12? Then I bet you 2 times 1.5 is 3, right? So if it involves multiplication, what is it? Exponential. So this is exponential data. And if remember, exponential looks like kind of a half of a parabola, half of a quadratic. Okay, so that's exponential data. So you're going to use the form y1 tilde, which is over on the board, ab raised to the x1 plus c. You will be given your a, b, and c if c exists. And you can write that equation. Go ahead and do that one. And then you're going to do the second C and see what you think that is. their first day of real high school math. Because we've been doing equations and stuff they should have been doing for years.
Okay.
So this is their first day of desmos. They're good class. And y'all notice when you're putting your data in on the left in that table, see that graph on the right? It shows you the graph. Shows you what the graph looks like. We got all math one should be on this today. If they're in the same spot I am. I don't keep up with him so much because he's an experienced teacher. I keep up with the newer ones and they're all in the same place I am. Y1 till AB raise the X1. Put a 1 with that X. There you go. There you go. Yeah. Everywhere you have a Y and an X, you have to have a 1. Subscript 1. So this, what is this data? Do you know what that is? Okay, but what do you do from one Y to the next Y, and that Y to that Y, and that Y to that Y? What is it? What are we doing? Okay. Okay. So now you're going to use, since you said it's exponential up on the board. Y1 tilde, exactly what I have on the board. That's why I have it on the board.
No, yes, I know, but what do you think?
Just put it in and you'll see, Ava. Don't fight the system, just put it in. Y1 tilde, AB raised to the X, caret, that little caret key. Put a 1 with that X. No, not with a B. Get rid of that 1. Okay, go up to the X. It can't be capital. I'll have to take that X out of there. It's capital. It's lowercase x. Now put a 1 with it. Gotta get that 1 out of there. Yeah, put it up there. No, back it out. Back it out again. No, back it out. Back it out again. Back it. Okay, now put a 1. It is what I have on the board. I've got A, B raised to the X1. My God, we're going to argue again today? Oh, we'll do it. If you want to do it, we'll do it. But I'll walk right over here and I'll show you that it does not have a 1 with the B. It has a 1 with the X. Please stop trying to fight the system. Just put it in, my God. Okay, you don't have a plus, you got a BXTC. That's a plus C. You don't have a 1 with your X. Everywhere you put a Y and an X, you have to put a 1. You just put it in, it'll subscript it. If you don't do that, it won't give you the information that you need. You probably did. I haven't done mine yet, but what does this say? What does it say? A3, B2, is that what A and B are? Then you'd put Y equals, let me show you, hold on, just hold that thought, okay? All right, so I'm gonna go ahead and switch back over to the other computer so we can put this data in. I don't know who's trying to go to the bathroom. You're not going. Not in the middle of my lecture. I don't do bathroom passes in the middle of a lecture. No other teacher does either. Just doesn't happen. Okay. Now, let me switch off of here. Okay? And we're going to go on to here. And I'm going to answer the question that Matt asked. So I'm going to put in the second one. We already know that that is, and by the way, I could go up here and I can X all this stuff out to start over. Y'all can see me, yeah? Okay. Now, I'm going to put in the data -1, 0, 1, 2. And then I could go over here and put in a 1.5. 3, 6, and 12. Okay, I know that's exponential, so I'm going to pull the exponential one. y1 tilde ab raised to the x1. And it tells me a equals 3 and b equals 2. What I do at that point now is I write the equation. And the equation, if I write the equation, this is what it looks like. Y equals A equals 3 times, A and B are next to each other, that's multiplication. 3 times 2 raised to the x, and there is no c. I didn't put a c in either. Maybe change that. I want to put my c in. See what c is, because I have to explain that. Okay, so c is 0, so there is no c. So when I tell you to give me the equation, this is what you are giving me. Yes.
If we ever had to like log it into a computer, would we have to put the +0 or no?
No. If it's a +0, just leave the 0 out. Yes.
So mine shows different stuff.
Yours shows what?
Shows different numbers.
Okay, so let me come and look at what you got. You probably made a mistake putting the table in. Yeah, that's an interesting. Okay, here's the problem. See how these have a 2? Okay, well, they should have a 1. But since they do have a 2, that's fine. Go down here and change that 1 to a 2. The reason we use 1 is because that's usually got 1. Change that to a 2 and change that one there to a 2. Okay, so what I had to do with her, and I hadn't explained that yet, when you build your table, if you've only got one table on the screen, if you haven't opened another table up, maybe you're dealing with 2 tables. I only have 1 table, so my x is a 1 and my y has a 1. If I opened another table up, my x would have a 2 and my y would have a 2. If that's the case, I would have to make these 1s be 2s. So be careful, make sure this is 1 and this is 1. If I go down here and I'm going to open another table, watch what happens. See the 2s? Now I would have to use 2s with my x's and my y's. Does that make sense? Okay. Did I answer your question on what you do after you get your a's and your b's? So then you write your equation. The last one I had you do, you were doing c. What did you find c to be? What kind of data was that?
Quadratic.
Quadratic. Why is only one person answering me? Okay, are we confused or not confused? Confused, no, do this. Good, bad. Good, bad. Kinda. Okay? So most people are good. Got some kindas, practice. All right, so we're going to go ahead and do table C. So if I go over here, I'm going to X everything out. And I'm going to open a new table. And I'm going to open table C. So I have a -2, -1, 0, 1, 2. See how it does it for me? And then I'm going to go over here and put in 6, 3, 2, 3, 6, 6, 3, 2, 3, 6. Now I'm going to drop down. I know it's quadratic. Y'all already did it by hand, so I'm going to use the quadratic model up there. You have to know these models. You will not be able to take a cheat sheet with you on a test. You got to know those models. Those are called models. So I'm going to do y1 tilde ab, nope, ax1 squared plus bx1 plus c. So I find my equation as y equals 1x squared. You don't need the 1. You can just put y equals x squared. Y equals x squared. There's no b, so don't put 0b. Y equals x squared plus 2. That would be your equation. Y equals x squared plus 2. put one in front if you want, if it makes you feel better. That's what that equation would look like for that third one. Okay, so what I want for you to do, it's enough information for you today. You can now play with it some. You know, if I wanted you to predict something after you found the equation, then you would have to do the prediction. None of these are asking for the equation or the prediction, but all the rest of them are asking you to tell them what type it is. That's where you put linear, quadratic, or exponential, and then it wants the equation. Now notice on this one here and this one here, these two right here, they don't give you tables of data. They give you a graph, but they do give you points. You're gonna have to pull points off these graphs to put into your table in order to have a table, in order to find an equation. So like on this one right here, and you don't need a lot. We already know it's linear, that's a line. That tells me it's linear. So on here I could pull the point 0, -5 is there. 1, -2 is there. 2, 1 is there. Just pull points off of the graph. Over here, the same thing. What type of graph is this one right here? Anybody know? Exponential. Exponential. They give you 3 points. Put those in your table. And that's what you're going to use to get your equation. Is anybody confused about what I want? Then when you turn it, you still got some more back here. Same thing. Okay? So you're going to be finding the equation. What is the data using by hand? First change, second change, multiplication. What is the data? Unless it's a picture and you can look at it. Then you know what kind of data it is. What is the data? What is the equation? Any questions?